Good evening, friends. Glad you could be here. I see there's 10 of you here at the top of the hour, or 7:30, excuse me. Today, we're going to primarily focus on the law of sines, but of course, we will start with a little bit of review, as we always do. So as we're waiting for 7:30 to actually arrive, let me go ahead and put the problem up I'd like you to take a look at. Oops. And I'll try to get this in a good place. So you can see what that says. It says a security camera in a neighborhood bank is mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed at a spot 9 feet above the floor and 12 feet from the wall? So what we did in our last lesson was to look at right triangles, and that's what this will be. Today's lesson on the law of sines, we'll take a look at oblique triangles as well. Zoe asks, meeting tomorrow in SEO 430. Yes, I plan to be there during my class times of 10 a.m. and 1 p.m. I will be there helping students work on problems. So I expect I'll put some sort of a worksheet together. If you're able to come, please do so. If not, I'll do my best to get those problems to you. Now, to do this one, we need to do what? We need to construct a graph. So can you visualize that? We have a wall. It's 9 feet above the floor. We're looking for the angle of depression. The camera is going to hit a spot. So the sweet spot, the focal point, is 6 feet above the floor and 12 feet from the wall. So here's the picture that I drew. Is yours something like that? There we go. So the triangle of interest is really the triangle on top. So if we're going to go ahead and do our analysis, this dotted line is 12 feet. And if it's 6 feet here and 9 feet here, I hope it's obvious that this is 3 feet on this side. So we have opposite and we have adjacent. I could get this hypotenuse using Pythagoras, but I'm going to choose not to. What I'm going to do instead is I'm going to use tangent. Remember, of course, that the tangent of theta is opposite over hypotenuse. So what I have here, tangent of theta is here. Excuse me, opposite over adjacent. That's the advantage of tangent, is I don't need the hypotenuse. So in our picture here, tangent of theta, opposite of theta is 12. The adjacent leg to theta is 3. So I have tangent of theta is 4. So if we didn't have a calculator, the best you could do is say that theta is the inverse tangent of 4. But I do have a calculator here that I will put in radian mode as well as degree mode to see what that is. So there's two possible ways for me to answer that. So from the radians perspective, the inverse tangent of 4 gives me what? And again, I'm going to check my mode. Inverse tangent of 4 is 1.326 radians. So a little bit more accuracy than I should use based on my significant figures. Going to degrees. We'll do that next. Change my mode if I can remember how to do that. Mode degrees. Again, inverse tangent of 4 is about 75.96. Let's call it 76 degrees. So I believe that's the angle of depression. The angle of elevation over here would be the complement. So if I call this angle alpha, the third angle here is a right angle. So we don't need to use the law of sines. Third angle is a right angle. And you'll recognize that theta and alpha are complementary. Remember, two angles are complementary if they add up to 90. So let's just go ahead and remind ourselves of that mess. Whoops. Two angles are complementary if they add up to 90 degrees. So in this case, theta and alpha are complementary. So theta plus alpha is 90. The third angle is also 90. Add them all together, you get 180. So theta is what, about 76 degrees? Plus alpha is 90 degrees. So alpha is 90 minus 76. I made a mistake with my subtraction last time. Try not to make any tonight. Alpha is 14 degrees. So that would be considered the angle of elevation. The angle of depression would be 76 degrees. So quickly to write that. Angle of depression is about 76 degrees. But again, you're not going to have access to a calculator on the exam, so the best you can do is this answer here and say that theta is the inverse tangent of 4. Okay. Let's go ahead and take a look at a review question before we jump in to this stuff. I want to do one or two trig equations, also very important concepts that we've been working on lately. So let's take a look at those. So the problem I want to look at is as follows, and I apologize for the fuzziness. What if I have cos 2 theta plus 6 sine squared theta is 4? And for the sake of this discussion, let's say that we're going to find all solutions in the interval from 0 to 2 pi. Where 0 is less equal to theta is less than 2 pi. So that's going to be our goal. Now, how are we going to do this? Let's go through the process that we need to go through for this to make some sense. Well, we've got to remember our double angle identity, and this is one of our favorites. Focus, please. Cos 2 theta is cos squared theta minus sine squared theta. And then what can I say about that? Well, I need to keep sine squared theta. So we recognize that cos squared theta is 1 minus sine squared theta. How do we know that? Cos squared theta plus sine squared theta is 1. So I can replace subtracting sine squared from both sides. Cos squared theta is 1 minus sine squared theta. So I want to make that substitution here. Cos squared theta, we said, is 1 minus sine squared theta. Minus sine squared theta. So now I get cos 2 theta is 1 minus 2 sine squared theta. This is another one of the double angle identities for cosine. But, you know, I don't expect you to memorize this one, but I do think you should memorize this first one because that's the one that you can use to develop all the other ones that you need. Okay, knowing that, let's go back and try to solve this equation. So my original equation is cos 2 theta plus 6 sine squared theta is 4. And I'm going to replace cos 2 theta with 1 minus 2 sine squared theta. So let's do that. 1 minus 2 sine squared theta plus 6 sine squared theta equals 4. Okay. So 6 minus 2 is 4, so I get 1 plus 4 sine squared theta equals 4. Let's subtract 1 from both sides. So now I have 4 sine squared theta is 3. Divide both sides by 4. Sine squared theta is 3/4. If I take the square root of both sides, square root of sine squared theta is plus or minus the square root of 3/4. So will that give me? That will give me sine of theta is plus or minus root 3 over 2. And we're looking for the answers between 0 and 2 pi. That's how we establish this. So the positive version, sine of theta is root 3 over 2. The negative version, sine of theta is negative root 3 over 2. Our reference angle in each case, reference angle is pi over 3. So what can we say then? Sine is positive in quadrant 1 and quadrant 2. My quadrant 1 answer, theta is pi over 3. My quadrant 2 answer, theta is pi minus pi over 3. 2 pi over 3. For a reference angle of pi over 3 where sine is negative in quadrant 3 and quadrant 4. Quadrant 3, theta is pi plus pi over 3, which is 4 pi over 3. And in quadrant 4, we get theta is 2 pi minus pi over 3, which is 5 pi over 3. So I believe we have all 4 answers in the interval from 0 to 2 pi. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. I like to express those in set notation. So I like to draw curly braces and write all those down. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So before we get into our discussion on law of sines, I want to do a quick review of a trig equation as well as a quick review of a right triangle trigonometry situation. So we're going to begin our discussion on law of sines now. So how is that going to work? Let's take a look at a triangle that is not a right triangle. So we'll go ahead and use maybe an obtuse angle in the triangle. If you have an obtuse angle in the triangle, you cannot have a right triangle. So maybe something like this. Okay. And let's label the various points here that we're working with. So what should I label them? Here becomes a convention. I have 3 angles. I have angle A, angle B, and angle C. I'm going to call this angle A, this angle B, and this angle C. The convention is to write the side opposite the same. So this is angle A. Side A is opposite angle A. This is angle B. Side B is opposite angle B. This is angle C. Side C is opposite angle C. I don't want to worry about C right now. I want to focus on A and I want to focus on B. What I'm going to do is now I'm going to drop an altitude. So we're going to drop this thing right here that is now a right angle. And I want you to see 2 different triangles. We see this triangle. And if we look at that triangle, we'll call that thing in red height, or H. If I call the thing in red H, what can I say? Sine is opposite over hypotenuse. So sine of A is H over B. Let's go ahead and say that. Sine of angle A is H over side B. And again, H is the same thing here, right? I mean, H is, whether I label it on the left side or the right side, it is the same thing. But if I look at this triangle now, whoops, what can I say? Sine of B is opposite over hypotenuse. So the sine of B, angle B, opposite is H. Hypotenuse is A. Okay, well, where to go next with this? Let's solve for H. So if I multiply by B on both sides here, I get B sine A equals H. On that side, I get A sine B equals H. So if that's the case, these 2 H's must be equal to each other. So if the 2 H's are equal to each other, B sine A equals A sine B. Now let's go ahead and divide both sides by AB. Divide the left side by AB, divide the right side by AB. Certainly neither A nor B are 0, because if they were, we wouldn't have a triangle. And you'll notice that the B's cancel, the B's divide out, I get sine A over A. equal, the a's divide out, equal sine b over b. And that is the first part of our generalized sine rule. Again, this works for oblique triangles. They don't have to be right triangles. But we used what we knew from right triangles to develop this argument. But I'm going to add one more piece to this because there's nothing really special about A and B. So here's our general law of sines. And that's what we'll be using to solve most of our problems today. Sine A over A equals sine B over B. Equals, third part, equals sine C over C. So I'll leave it to you to convince yourself of that, but it's the same argument. You just go ahead and draw the triangle a little bit differently, maybe compare B to C instead of comparing A to B. Okay, so let's take a look at an example, and we will try to solve the triangle. So that's something that I often ask you to do. So just so we're clear on that, if I ask you to solve the triangle, we need to have 6 bits of information. I need angle A, I need angle B, I need angle C, I need side A, I need side B, and I need side C. So here's the first example that we're looking at. We are going to have a triangle like this. And I am putting 100 degrees here. I am putting 30 degrees here. I am calling this thing A. I'm calling this thing C. I am calling this thing 6. So if that's the case, the third angle that I would have, this is little c, so opposite little c is angle C. So I guess if that's A, this is angle A, so this must be B. So as we start with our givens, what are we given in this problem? Do we know what angle A is opposite little a? Sure. Angle A is 100 degrees. Do we know what angle B is? Angle B is opposite little b. Angle B is 30 degrees, and we know what little b is. Little b is 6. So you can see I know angle A, angle B, and little b. So yes, I could use law of sines to find something, but why don't we find angle C first? Because we know the 3 angles of a triangle add up to 180 degrees. So we know angle A plus angle B plus angle C has to equal 180 degrees. So we have right now angle A is 100 degrees plus angle B is 30 degrees plus angle C is 180 degrees. So this is certainly simple. And we get angle C is 50 degrees. So there's 2 more things we need to find. We need to find a little a and we need to find a little b. So let's use the law of sines. We've got the law of sines on the top of the page here. So I've got sine A over little a equals sine B over little b. I know angle A, I know angle B, I know little b. That'll enable me to go ahead and solve for A. So let's do that. So writing down our law of sines, we have, again, sine A over little a equals, we're going to start with sine B over little b. Sine of A, what is A? 100 degrees. Sine of 100 degrees over little a is what? Unknown. Equals sine B, sine 30 degrees over little b, which is 6. Multiplying both sides by 6a. Multiplying the left-hand side by 6a, the a's cancel. I get 6 times sine 100 degrees. Multiplying the right side by 6a, and I get a times sine of 30 degrees. And my goal is to solve for a. Well, I happen to know what sine 30 is. It's a half. Might as well use that. So we'll say 6 times sine of 100 degrees is a times a half. So to solve for a, multiply both sides by 2, multiply the left side by 2, multiply the right side by 2, and I have a. What do we get? We get 12 sine 100 degrees equals a. All right, you're saying the audio is not good? Oh, I'm sorry to hear that. If that continues, tell me. But even if the audio is not great, if you have to go ahead and mute me, hopefully you can follow the work that I'm doing. Have we solved the triangle? We have angle A, angle B, little a. We're missing little c. So there's one more thing that we have to do. So let's go ahead and try that. Certainly, if I would do this all semester, I would buy an expensive microphone, but I'm just using the mic in my Apple MacBook, I think is what I have. Let's go ahead and do our last piece of this. So I need to figure out what C is. So I'm going to use this version of law of sines. Remember, we have this. Sine A over A equals sine B over B equals sine C over C. I'm going to use this part. Sine B over B equals sine C over C. Let me write that down. Sine B over little b is sine big C, sine angle C over little c. Sine B again, sine 30 degrees over little b is 6, is sine C, we said C was 50 degrees, over C. Multiply both sides by 6c, which, yes, is equivalent to cross multiplying. So I get C times sine 30 equals 6 times sine 50 degrees. Sine of 30 degrees is 1/2. Is 6 times sine 50 degrees. Multiply both sides by 2 again. And I get C equals what? I get C equals 12 times sine of 50 degrees. And now I believe we have all 6 pieces of that triangle solved for. So that should work for us. I'm going to try to get a little closer to my microphone, see if that helps. We've solved the triangle. Whoops. The only thing I'll say is that on the exam, we will not have a calculator, so you're not going to be able to go any further. This is as far as you're going to be able to go. I have a calculator with me today, so I'm certainly able to go ahead and approximate these things. So 12 times sine 100 degrees. Checking my mode to make sure I'm in degrees. I am. 12 times sine 100 degrees is about 11.8. And 12 times sine 50 for C is about 9.2. So we have all 6 pieces. But before I go on, I want to spend a little bit more time looking at that triangle. What kind of a triangle was it? How were we able to solve it? What were we dealing with? Okay. So here we go. I have 2 angles, and I have a side that is not in between those 2. So if we're going to classify that with those 2 angles and a non-included side, again, this is 30, this is 100, and this is 6. Angle, angle, side is what we have here. So the law of sines is helpful for certain triangles. Now, if you have 2 angles, you have 3. So we certainly could also say ASA if I have 2 angles with an included side. That'll also work for us in this situation. The challenging one, of course, is the ambiguous case. So if I have AAS or ASA, we have one solution, always. The ambiguous case is SSA. Of course, if you put the A first, might be easy to remember that that's a problem. If you have two sides in a non-included angle, you may have no solutions, you may have two solutions, you may have one solution. So, if we look at an SSA case, we've got to keep in mind that that one may get tricky, and we'll see how that works. All right, so let's go ahead and do another problem, keeping all these things in mind. This time I'm going to just give you the three letters, and then we're going to try to build the triangle. So here is what we have for that, as my computer doesn't want to focus till I start writing. So I'm going to say A is 40 degrees, B is 40 degrees. And little c is 2. Well, I hope it's obvious. Let's draw ourselves a picture. That's an isosceles triangle, isn't it? Both with 40 degrees. Well, these are supposed to be the same size. So if this is 40 and this is 40, this is my A angle. So opposite A is little a. This is my B angle. So opposite B is little b. Therefore, this will be my C angle. Opposite C will be little c. We know the three angles have to add up to 180. So angle A plus angle B plus angle C is 180 degrees. 40 plus angle C is 180 degrees. Therefore, angle C is 100 degrees. And I've just got to go ahead and I've got to find what? I've got to find A and B, but it's an isosceles triangle, so I know A and B will be the same. But I have to work off of C. You'll see I know little c and I know angle C. So I'll start with sine C over C would equal sine A over A or sine B over B. Let's say that. Sine C over C is sine A over A. Sine C, sine 100 degrees over C, which is 2, is sine A, sine 40 degrees over A. Multiply both sides by 2A. Let me actually go ahead and do that this time rather than just skipping that. Multiply both sides by the common denominator, which is 2A. You'll notice the 2's cancel, and I get A times sine 100 degrees. The A's cancel here equals 2 times sine 40 degrees. Divide both sides by sine 100. And what do we have here? We have A equals 2 times sine 40 divided by sine 100. And let's see what that is approximately. Again, I have my calculator with me tonight. In degree mode, that's the mistake most people make, is they forget to change the modes. 2 times sine 40 divided by sine 100. And I get about 1.3. 1.31. And all I'm going to say is we recognize that this is an isosceles triangle. So A and B have to be the same. So therefore, B will also be 2 times sine 40 degrees divided by sine 100 degrees. Now, what kind of a triangle did I have? I gave you angle A. I gave you this angle. I gave you this angle, and I told you C was 2. So I have two angles. I have AA with the side in between. So this case is an ASA triangle. When I am given an ASA triangle, we always know that we have one solution, which we've done. So I have little a, little b, angle C, angle A, angle B, little c. I have completely solved that triangle. All right. Let's take a look at another example. We're going to continue to make these a little bit more challenging. So I'm going to give you the 3 letters, and we'll see what we get. I haven't asked you to do any work yet today, so maybe I'll have you guys try this first for me. So I've got little a is 4. We have little b is 5. And we have a is 60 degrees. So here's what I'd like you to do. I'd like you to go ahead and draw the triangle. Whoops. Focus. I don't know why that doesn't want to focus. Here we go. Go ahead and draw the triangle. And in the comments section, please tell me. Okay, we'll leave the pen there. Go ahead and draw the triangle. And in the comments section, tell me what kind of a triangle it is. Is it an ASA like we saw before? Is it an AAS? Is it something else? So see what you can do. Put the type of triangle you think that is in the comments, and then we'll do our best to try to solve it. Jeff says SSA. Stacy says SSA. Rowan says SSA. And yes, all of you are correct. So I have A, I have B, which is over here, and I have, so A is 4, B is 5, and angle A is supposed to be 60 degrees. So here's angle A is supposed to be 60 degrees. All right, so we have a side, and the angle that's not in between them. So indeed, that is an SSA angle, and that does not make us happy because we might have one solution, we might have 2 solutions, we might have no solutions. So yeah, the SSA case is the most troubling case. Now, okay, fine. We have A and A. If this is side B, this would be angle B over on this side. So let me go ahead and use that information to see if I can find out what angle B is. So let's use our definitions here. Sine A over A equals sine B over B. What is angle A? 60 degrees. Sine of 60 degrees over A, which is 4, is sine of B over little b, which is 5. Okay, that's great. Multiply both sides by 5 times 4. Common denominator stuff. Multiply this side by 5 times 4. Multiply this side by 5 times 4. The 4's cancel. Divide out. I have 5 times sine 60 equals 4 times sine B. And I'm in a shadow, and I'm sorry about that. So if that's the case, divide both sides by 4. 5 sine 60 degrees divided by 4 is sine B. But here's the thing. 60 degrees is root 3 over 2. So I get 5 times root 3 over 2 divided by 4 is sine B, which is 5 root 3 over 8 is sine B. Now I would like to have a calculator. So I'm going to pull it out and I'm going to see what is 5 root 3 over 8. 5 times the square root of 3 divided by 8 is 1.08. 1.08 equals sine B. And there's my second unhappy guy on this problem. Can sine be 1.08? Can sine be 1.08? I don't think so. Sine is always between -1 and 1, so this has no solution. So this SSA case cannot be solved. But the issue is when we have SSA, yes, you may have no solutions, which is what we have here. You could have two solutions. You could have one solution. So the SSA case really is the most interesting case for us to look at. But it can be unpleasant, again, because we're not exactly sure how it's going to turn out. All right, let's take a look at another one and see what we can do. And I know this is when the autofocus goes crazy. So I should leave my pen on the paper. I think we've learned that lesson. Leave a green pen, I'll write with the black one. So what I'm going to tell you here is little b is 4. Little c is 3. And angle B is 40 degrees. So we always want to try to draw a picture first to get a feel for how this is working. How will we know it will have no solution without a calculator to solve? Stacy, that is a really good question. On the homework, I'll let you use a calculator. On an exam, I won't. So I'll have to figure out some way on the exam to get that information to you. So, but I will keep that in mind. Okay, let's draw a picture. We have B, we have C, we have angle B. I'm not going to try to draw this to scale. This is angle B, which is 40 degrees. Opposite angle B is little b. So I could put C in either place. It looks like it's supposed to be smaller from my picture. That doesn't look likely, but okay. I'll put C equals 3 here, which would make this angle C, would make this angle A, and would make this little a. So Stacy's question is going to be relevant again here in that how are we going to do that without a calculator? But let's keep focusing on it and see where we can get. So we'll take this version of the law of sines. Sine B over little b is sine C over little c. Do I have enough here? Yes, I think I do. Sine of B is sine 40. Excuse me. Sine of 40 degrees over little b, which is 4, equals sine of C. I don't know what that is. Over little c, what is little c? Little c is 3. I want you to recognize again, two sides, non-included angle, SSA, unhappy, because that's going to be challenging. So this will give me 3 times the sine of 40 degrees equals 4 times the sine of C. So 3 times sine 40 degrees divided by 4 equals sine C. What's that going to give me? Again, to my calculator, 3 times sine 40 divided by 4, I get 0.482 approximately. So sine C is about 0.482, which means C would be the inverse sine of about 0.482, maybe. So what is the inverse sine of my previous answer? I get 28.8 degrees. So that's angle C is 28.8 degrees. Or, remember, if sine C is positive, I could also have a quadrant 2 angle, couldn't I? So I need to check if that quadrant 2 angle might actually work. So angle C could be 180 degrees minus 28.8 degrees. What does that make angle C? 180 minus 28.8. I get 151.2. Is 151.2 possible in this problem? No, because you'll notice angle B up here is 40 degrees. So if I have 151.2, a strike is making me sick. If I have B is 40 degrees and C is 151.2, we're over 180, and that's no good. So we don't need to worry about that. So let's put all this together to try to solve the problem now. So we will say then that I have angle C is 28.8 degrees. Angle B is 40 degrees. So angle A has got to be 180 minus 40 minus 28.8. 180 minus 40 minus 28.8. So angle A is how much? 180 minus 40 minus 28.8. And I get 111.2. Only one solution. Our first SSA case, we had no solutions. Our second SSA case, we have one solution. And you'll recognize there's only one thing I'm missing. I have BC, I have angle A, B, and C. I am just missing little a. So if I'm missing little a, I will use the law of sines to go ahead and solve for that. So that, of course, is sine A over A equals either sine B over B or sine C over C. Sine A, we have angle A now. Over little a, we don't have that, is sine B. We know what angle B is. Over little b. Sine A, sine 111.2 is sine B is sine 40 over little b. Little b is 4. So 4 times sine 111.2 degrees is a times sine of 40 degrees. So if I divide both sides by sine of 40, I get 4 times sine 111.2 degrees divided by sine 40 degrees equals a. Let me get myself an approximation for that if I can. 4 times the sine of 111.2 divided by the sine of 40. And I get about 5.8. And I'm checking to see if that's what is on my sheet here. And it doesn't appear that they've actually done that, but I have. So A is approximately 5.8. So we've got all 6 pieces, little a, little b, little c, angle B, angle C, angle A. We have solved the triangle. Again, that was an SSA triangle that had one solution. SSA triangle that had one solution. So you can probably guess where we're going to go next. And this may be the last problem we can do with the time that we have. So here we go. Law of sines. We, of course, will continue to work on these on our next lecture, which I very much hope will be in on campus at UIC once the strike is over. Okay. So here we go this time. I want B to be 2, C to be 3, B to be 2, C to be 3, and angle B to be 40 degrees. So I'm going to pass on drawing the triangle this time. We're going to go straight to the law of sines. Sine B over little b is sine C over little c. Sine B, sine 40 degrees over little b over 2 is sine C. That's what we're going to find. Sine C over little c, which is 3. Multiplying both sides by 3, 3 times sine of 40 degrees over 2 equals sine C. Okay, so I'm going to start with the inverse sine. What is the inverse sine of 3 times sine 40 degrees divided by 2? What is that? Let me find it. 3 times the sine of 40 degrees divided by 2, and then take the inverse sine of that. And I get about 74.6 degrees. So I could say C is 74.6 degrees, or C is 180 minus 74.6 degrees, which is how much? 180 minus 74.6 is 105.4. So this time, is that possible? Does that work for us? Well, 105.4 here degrees, 40 degrees there. Do we still have room for us to use? 105.4 and 40 is 145. So yeah. So we have two cases that we have to try to solve. Two cases here for us to work with. I don't think we're going to quite have enough time to do both of them. Case 1, fine. Little b is 2. Little c is 3. Angle B is 40 degrees, and angle C is 74.6 degrees. That's case 1. Case 2, again, the initial conditions are the same. Little b is 2. Little c is 3. Angle B is 40 degrees, but this time angle C is 105.4 degrees. Maybe we have time. Angle A, we know these guys have to add up to 180. So what's 180 minus 40 minus 74.6? I get 65.4 degrees. And over here, what's angle A? 180 minus 40 minus 105.4. 180 minus 40 minus 105.4. And I get 34.6. So the last thing that we need, of course, is little a. What is little a? What is little a for my two cases? That's what we'd want to find. Well, we certainly can do sine A over A equals sine big B over little b. Sine A, I'm looking for A. Oh, no, I'm not. I know what A is. I think I want to use a new piece of paper here, just so we have enough room. Sine A over A equals sine B over B. So sine 65.4 over little a is sine B. Sine 40 over little b over 2. So to that, what can we say? We can say 2 times the sine of 65.4 is a times the sine of 40. And then we can divide both sides by sine of 65.4, excuse me, sine 40. 2 times sine 65.4 over sine 40 equals little a. What's that going to give me? 2 times the sine of 65.4 divided by the sine of 40. And I get 2.8 approximately. So that's my first case. My other case, again, done the same way. Sine A over A is sine B over B. This time sine A, sine 34.6 over A is sine 40 over 2. So 2 times sine 34.6 is A times sine 40. 2 times sine 34.6 divided by sine 40 is A. Pull out the calculator one more time. 2 times the sine of 34.6 divided by the sine of 40. 2 times sine 34.6 divided by the sine of 40. And I get about 1.8 this time. 1.8 is approximately equal to A. Is that what they have over here? Just checking. Somewhere in that neighborhood. All right. So SSA case. SSA case, you'll notice what we have here. 2 possibilities for us to work with. So we saw no solutions, we saw 2 solutions, and we saw 1 solution for the SSA case. That certainly is the most challenging. All right, friends, I hope you made some sense out of the law of sines, as well as our brief review on recently studied topics. I really hope that we are back on campus on Monday. So, check your email. I'll keep you updated. And if you are in my class, please consider stopping by tomorrow, either at 10 a.m. or at 1 p.m. Come by SEO 430, and I will have some problems for you to work on. And the learning assistants are there, and they can help you. So there tends to be a small number of people there. So I really encourage you to come by. The discussion sheets are also posted online. If you haven't done those, you might want to copy those and bring them in if you're going to come and do the work session tomorrow. All right, my friends, again, let's hope this is the last one of these we have to do. Have a great weekend. Hopefully I'll see some of you tomorrow. Bye-bye.